I'm on page 45. When I was teaching this to HiSET students, I always started this lesson out with some sugar cubes and Elmer's glue. And I had them to literally build the models that we're looking at. Because once you do that, you understand what volume feels like, what it literally means. So the question we want to answer is how many cubic units are needed to construct this model. Now this one's not too bad because I can simply count the cubes. I have to use my imagination a little bit to know what I can't see, but I can literally count the cubes. Now the way I would approach this if I were building this model, I would take 4 sugar cubes and glue them together to make a unit. You don't have to do it this way, but this is one way that you could think about it. So one unit here, one tower, is 4 cubes long. 1 cube wide, 4 cubes long. So here would be another one. So count these as we go. How many cubes does it take to construct those 2 units? Well, it takes 8. We have 4 and 4. And then I'm going to build this unit as one unit. So there's 4 on the top, stacked on 4 on the bottom. So that's a total of how many? Yes, 8. You get the gist. I promise I'm not going to do this on all of them. I want you to see the pattern that I'm building here. Then we have 3 units of those 4, so you can visualize what's stacked underneath even though you don't see it. And you may be thinking, well, how do you know it's there if I don't see it? I know it's there because for that top row to stand up, the bottom 2 have to be there. So 4 times 3, that's 12. And then finally we have this unit over here that I see as one big unit. So it is 4 rows high. It's 4 rows across, so we're finding area. A 4 by 4 is 16 of those little cubic units. So to get the volume of this thing, because remember volume is the number of cubes. This is the part I can't do. We have 16 plus 16, that's 32. 44. 4 plus 4 plus 8 plus 12 plus 16 is 44. So the volume is 44 cubic units, or 44 units cubed. So once you get the feel for this, you literally can visualize what's going on. Let's move to the next one. How many cubic units Now, I could do the same thing. I'm not going to. I could color them, do it that way. But this time I'm going to use math. I'm going to count the number of cubes on the length. And when I say the length, I am going to shade that for you. So there are 4 cubes going this way in this structure. So the length is 4 units. Now, if I knew if those were inches or feet or miles, whatever, I would use that, but I don't. All right, let's count the cubes going this way. And I'm hoping this will work the way I think it will. It did. Not quite the way I thought it would. I was hoping this one right here would be an obviously different color, but it's okay. That one's being shared, but you still have to count it. So the height is 4 units. And now let's get the width. I'm going to go this way with the width. There's 1, 2, 3, 4. Which makes sense to me because if it's a perfect cube, they have to be the same. That's what makes a cube a cube. The length, the width, and the height are all the same. So to find the volume of a cube, you can use a formula. Volume is the length times the width times the height. So volume is length times width times height. Length is 4, width is 4, height is 4. Volume is 4 4s are 16 times 4. There are 64 of those cubic units that were needed to build this cube. You can also write it this way. So I would need 64 sugar cubes to build this cube. If I finished this cube, it wouldn't be a cube. It would be a 5 by 4 by whatever dimension, 5 by 4 by 4. But as it's cut away, it's not a complete unit. So that gives you an idea of what volume is. Let me show you one more without a picture. So let's suppose that I don't draw all the cubes, but I draw it this way. Okay, there's a square. That's 2 by 2. Gonna copy that because I need another one just like it. Another 2 by 2. And then I'm going to connect the vertices, hopefully in a straight line. So you see this cube is coming together. Even though I can't see all the little units, I know that this is 2 units wide. It's 2 units tall. And it's 2 units this way, wide. So given that information, I can find the volume of the cube. I don't need to see the sugar cubes because I can figure it out. 2 times 2 is 4, times 2 is 8. So this is 8 cubic units that it would take to fill that shape. Or you could write it as 8 units cubic. Sometimes the volume formula for a cube is given to you this way, where E stands for edge. If it's a cube, the edges are all the same, so that will absolutely work. Because look at what it does. It brings you back to that same problem that will still equal 8. Now, we are going to learn formulas for different shapes. The cube is by far the easiest one. But as the shapes get more complicated, the formulas get more complicated. but we're going to tackle those on page 46. I will show you how to do all of those. We'll even do another cube. But this helps you to grasp the concept of volume, what you're talking about. Volume is always in cubic units. Area is square units. Let me just remind you of this because it's important. Perimeter or circumference are in units, just linear units. So those are not square or cubed or anything. They're just units. Areas are always square units. They're two-dimensional. Length, width, base height, they're square two-dimensional units. Area is covering something. Perimeter and circumference are going around something. Volume is always cubic units, just like we saw here, because volume is talking about capacity. It's filling something to capacity. So those different reasons for doing the math give you the units that you need to remember.